Everyone, let's continue correlation analysis, and today we will discuss partial correlation. And partial correlation we are using with the help of Jamovi. And same case we are going to take it into consideration. This was the case that I had already shared our one previous video, and this video, right? You can see in this video I had explained you correlation matrix, but here is we will discuss only partial correlation. And on the basis of the same case we would run in Jamovi. And first of all, we would understand what do you mean by partial correlation, where we are going to apply. So basically, partial correlation calculates the correlation between two variables. That is the correlation between two variables while excluding the effect of a third variable. This makes it possible to find out whether the correlation between variables x and y is produced by the variable z. There is the third variable that is also correlated. So the partial correlation tells how strongly the variable x correlates with the variable y if the correlation of the both variables with the variable z is calculated out. So here is, I have taken one example like economic data on the consumption, income, and wealth of various individuals. Consider the relationship between consumption and income. Failing to control for wealth when computing a correlation coefficient between consumption and income would give a misleading result. Since income might be numerically related to wealth, which in turn might be numerically related to consumption, a measured correlation between consumption and income might actually be contaminated by these other correlations. So the use of partial correlation avoids this problem. So this is the graphical representation. Consumption is a x variable, income is a y variable, right? And there is the, we can say, wealth, that is z variable, right? So this is correlated, but there is, due to this wealth also, it's correlated. So how we can evaluate it and how we can run. And this is the interpretation of partial correlation with the help of SPSS. And this is the interpretation I had already written. And now same thing we would run in our Jamovi. Same database I'm going to use. This one is the database I'm using. Placement salary, and this data set I'm going to use salary, marks, communication score, GS score, and IQ score. So in this my case, salary, right, that is one variable, marks is another variable, and Z variable, control variable would be IQ score. So let's begin, and let me open this my data set. I think this is already open. Browse this, and after that I'm going to use the same database. And now we can see, and here is in regression, right? All these parameters, all the variables are here. Now we will go to regression and partial correlation. In partial correlation, salary is one of my variable and marks is another variable. But IQ, because we would like to see whether this is the correlation is same in the presence of IQ. But here it is. Now we can see p-value that is 0.001. And this one is the 0.702 relationship, right? R value is 0.702. So we can say there's a strong relationship between marks and salary, right? But when we would enter this control variable here, and now you can see Pearson correlation that is 0.332 and p-value is 0.114. It's not statistical significant. But when we will talk about, let me just share both these tables. Let me copy without IQ when I had not entered this. So we would just paste it here in my Word document. Right here, right? Correlation, this is this interpretation through SPSS. So I'm just pasting here over there. This is the one table without presence of control variable, and we will compare both these when in the presence of IQ. Let me copy this and we will compare in the Word document. So now you can see this is the difference. When this was Z variable was not here, only two variables, one is salary and marks. Now you can see this is the correlation value was 0.072 and it is statistically significant, means they are highly correlated, right? But when Z variable had entered, now correlation between salary and marks, because control variable, now you can see we had controlled this relationship, right? IQ. And this is the p value is now it's reduced, it's the 0.332, that is it's reflecting weak correlation, and this p value is also not statistically significant. So you can see how we can change these values and we can check biasness in the correlation. And now these are my through SPSS results. So same results you can see here. Let me show you. We can compare with the help of Jamovi also. Significance value exactly same we had found through Jamovi. And now we will come here how we are going to interpret the variables are we are controlling for the analysis have taken IQ. IQ is my control variable in this study. And same way, you can take it any controlled variable. The correlation coefficient is not just considerably smaller, right? That is 0.332. And here it is compared to 0. Earlier it was 0.702. And in case of bivariate, what the p-value is also much higher, 0.114 as compared to less than 0.05 in case of bivariate. This means that if we control the IQ level of the students, the salaries will not be significantly related to the academic performance of the student, which is good news for the lucky student, means there is no correlation. Those are meritorious, they are getting higher salary, right? So in these kind of partial correlation, it's very important. You have to apply in your study, and definitely biasness, we can remove this and we can reach towards the correct answers, right? Thank you. Stay tuned. Keep watching.